So in this tutorial, we are going to talk about the following concepts. We start with the CI/CD pipeline, so which covers about what is CI/CD pipeline, why the CI/CD pipeline is required, and how we are going to implement in real time the CI/CD pipeline. And then following, we have CI/CD tools, various tools or various open source tools available in the market on CI/CD that we will be talking as part of this tutorial. And then how we are going to set up the CI/CD pipeline through TeamCity, which mainly talks about the installation of TeamCity, configuration of TeamCity, and then once we have the TeamCity configured, how we are going to set up the agents in the TeamCity, which also talks about the user management and group management for providing various privileges to the users and groups, and running the TeamCity behind the HTTP server, which is more plain HTTP and also the secured HTTP. And then we have the installation of TeamCity plugin in IDE, and then how we are going to integrate TeamCity with the code version control system, that is Git, and how we are enabling the quality gates using the Sonar Cube, that we will be talking part of this training. So to start with CI/CD pipeline. So CI/CD pipeline actually is a backbone of DevOps. It's more becoming a common thing these days, which is automated process, avoids the uh, manual build and deployment process. So let's take a scenario where there is no CI/CD integrated to your project. Then, if three developers are actually implementing the application, when they are dealing with same code base, then one person has to wait until the another person completes his code, done the unit test, and confirms that everything is working fine. Then he will be sharing the data to the first person, and the first person can make use of the data and make a build and make a deployment, unit test it, and then giving back to the second person. So there is a complete dependency on of the developers, and it will more like a time consuming process, and you can't have right product at the right time. You have to wait for a long duration to get the product delivered and deployed. So to avoid this, we can go with CI/CD pipeline, or in fact CI/CD process. And let's take another scenario. You already have a version control available set up, and you are actually using the version control. You are checking in the code to version control, and other person can check out the code from the version control and then do the uh, coding, and he can directly test it on his local machine. But if the build has to happen and to give it to the QA team, if there is no CI/CD setup, then someone who is more called a build engineer or a release engineer has to see whether there is a latest code base available in the version control system. So there is a total dependency on a build engineer or a release engineer. Let's take a scenario where release engineer is on vacation for a couple of days. Then everyone has to wait until release engineer come back and do the deployment on the environments, unless release engineer builds and deploy the application on the environment, no one get the updated version of the application. So to avoid this particular situation, what exactly we are doing is we are setting up the both CI/CD pipeline through one of the CI/CD tools so that CI/CD takes care of the pulling the code from version control system and then building the application uh, and making the artifacts and then deploying the application on the requested containers. So that will be done automatically, which is actually taken care by the CI/CD. So look at the process that is actually following part of the CI/CD pipeline. So it is more similar to the Agile process, SDLC process. So if you look at the SDLC process, we have the requirement gathering, designing, coding, unit testing, build, deployment. And CI/CD pipeline is actually uh, be part of the build, before build, checking the code to the version control, and building the application once unit test cases are executed, and then deploying the application. So take the scenario that a developer actually done the code changes. It will move the code changes to the version control, and version control will have the latest code base, and then TeamCity, which is a CI tool, pull the data from version control and then make a build of it. So once build is completed and everything is fine and we have the artifacts generated, then that will be unit tested through the test framework. That could be JUnit or any unit. And then once unit test cases are passed, application will be deployed on the QA box, QA environment. And once the application is moved to the QA environment using one of the tool, again TeamCity in our case, there will be functional tests executed and regression tests executed, which are again through jobs in TeamCity. And once all functional or regressions tests are passed, then we deploy the application on the production environment. And in the production environment, there will be sanity test done or smoke test done, and validation will be taken care by the team. If all good, that is good to go. So this is a typical process we are following, part of the CI/CD pipeline. And the basic point is why CI/CD. We already talked about what will happen if you don't have the CI/CD. So there is a huge dependency on the human. There is a human intervention. So to using CI/CD, we can avoid human intervention. And next one is we can provide a faster software builds. So as I actually mentioned in the previous slide, so if you have CI/CD, CI/CD takes care of building the application and deploying the application within no time. So whenever there is a code checking happen, CI/CD takes care of building the application, deploying the application, running the unit tests. So everything will be part of the CI/CD there. So we can have faster builds, faster artifacts getting generated without waiting for a couple of hours, couple of days, depends on the if there is no human intervention. And when we have the packages already available, we can deliver those packages within no time to the customer, to the market. So that's what we call time to market. So time to market is very less, so that anyone who wants the artifacts, who wants the application, can directly take the application within no time. And as we actually integrate CI/CD with quality gates like Sonar Cube, so we can ensure that there is a code coverage happen, and there is a proper code coverage, and quality of the code uh, is good with no violations, with no code violations, no quality violations in the code, no security violations in the code. By setting up the Sonar Cube, we can run the quality gates, and we can make sure that we are delivering high quality code to the customer, and also we are delivering efficient code to the customer. And as we already set up the Sonar Cube, part of our CI/CD pipeline, we can make sure that every code which is checked into the version control is reviewed. So properly reviewed by the version control tool. So there is a very less requirement to have a manual code review. All the code review will be done by static code analysis tool, which is integrated with CI. That's TeamCity, and we can make sure that the efficiency of the developers is increased because they are not spending too much time on the things which can be automated, and they can concentrate on what they are asked to do, so they can deliver the quality code within no time. So next one is how to start with continuous integration and continuous delivery. There are many steps we have to, there are few steps we have to take care of for setting up the continuous integration and continuous delivery, or and continuous deployment. To start with CI, first step is we have to have a version control in place. There are many version control tools available in the market now. So in our case, we use Git, is one of our version control tool. And once version control tool is available, any developer who actually do the code changes can check in the code in the version control tool. And next one is we have to make sure that there are proper unit tests are available, and suggested way to follow the test driven approach. So TDD, we call it test driven development approach. In that approach, we are making sure that unit tests are existed for every functionality or for every code we are writing. And then once we have both version control and unit tests in place, we can set up the continuous integration tool, in our case TeamCity, and then TeamCity will actually takes care of executing the files, executing the builds through agents, and then taking care of build and deployment. So if you look at the typical process of CI/CD pipeline, which is actually narrated in the picture, first let's say managers and dev 1, dev 2, dev 3, all developers are checking in the code to the version control server or gate, and once code changes are done, TeamCity will fetch the changes, and then TeamCity will make a build of the changes. If there are failures in the version in the code, or if there are issues in the code which is checked in, it will send back a notification to developer with failed status. If this TeamCity build is success and tests are success, then it will notify the developer or and manager with the result, which is success of the build, and it will generate an artifact. So if you look at the CI/CD tools available in the market, there are many tools available in the market which are actually taking care of continuous integration. Many companies in the new era are in the modern modern technology, looking for having their own CI/CD tool, which can make them use of the continuous integration and continuous delivery and deployment. So we are not going to talk about all the tools available in the market, but there are famous tools which are used by many of the companies in the market, or Jenkins. This is a common, more common and one of the famous tools available in the market, uh, uh, which is open source in nature. And then we have TeamCity, which is the one we are talking about or going to talk about, is one of the matured continuous integration tool which has all the features which are required for build, deployment, and delivery. And we have another tools as well, which are like Bamboo, another tool for CI/CD, and GitLab, Circle CI, Travis CI, CodeShip, GoCD. All these are the tools available in the market which are famous and which are using by most of the companies in the market. So next talk about continuous integration with TeamCity. So TeamCity is actually implemented by a company called JetBrains. This is a company which is famous for IntelliJ IDEA, edit, IDE, and this particular TeamCity tool is available for free of cost for developers and build engineers, and it also have the professional license for production. So if you are actually want to use TeamCity for your builds, you can use the free version. But if you want to use this product for commercial, then you have to buy the license. So when you look at the TeamCity, there are many concepts available in TeamCity which are actually playing a important role. To start with, one agent. So this is the main part of TeamCity. This particular agent takes care of executing the builds which can be integrated within the TeamCity server or outside the TeamCity server. So this agent can be installed any of the servers or any of the missions which are physical or virtual in nature, and this agent can be installed on different platforms, could be Windows, Linux, or any other platform. So this agent is the main component of TeamCity. If you want to run a build, you have to run through an agent. Agent takes care of running the build, and then generating the artifacts and sending the artifacts to the artifactory or any other tool. And then we have TeamCity server, which is more like the jobs, monitoring the jobs and monitoring all the build agents. So it will check uh, how the builds are happening, and if there are parallel builds, how these parallel builds are happening without any issues. And if there are continuous builds or multiple builds, TeamCity server takes care of queuing those multiple builds so that one build success, then the next build can be executed through the agent from pulling from the queue. And this actually TeamCity server is responsible for uh, publishing the result, which could be success or fail, and it takes care of uh, publishing the build results, build history, and build status. And if there are any changes done in the version control, let's say that you are using one mission, one version control server today, and tomorrow you want to use another version control server, that will be configured in TeamCity, and TeamCity will monitor the changes done in the version control changes. And also it will takes care of queuing the build. Say that I already checking the code, and when a build is happening, some other person checking the code. So in that case, if already one build is executing, TeamCity keep the another build, another request in the queue, so that once my request completes, once my build is completed, the next request will be active, and the TeamCity takes care of building that. And TeamCity also takes care of permissions, notifications. Uh, there's more like how user creation, and taking care of the user management. And we can have multiple user groups, normal user, admin user, or operator. So these groups will be defined part of the TeamCity server by connecting to either internal database or external database. So TeamCity by default uses hypersonic SQL, which is a in-memory database. We have the provision to connect TeamCity with external database, that we are going to talk in our further sessions. And then we have build configuration. So build configuration is mainly about how the builds are going to happen, how we are going to get the that code from version control, how we are going to run the build, and part of the build process, how we are making sure that unit tests are executed, where the artifacts are going to be placed once they are generated, and how these artifacts going to be deployed on different containers. So that is taking care part of the build configuration. And build configuration also takes care of sending out the notification to the end user, to the developer or manager, once build is completed. And then we have VCS root. So this is more version control information. So it gives you information about what is the version control used for fetching the data or fetching the code, and how we are going to connect to the version control by providing the username and password. And it also gives information about the code tracking or change management, if there are any changes done in the version control. Or let's say a code is checked into the version control, it will be notified to the TeamCity, so that TeamCity can fetch the data, fetch the code from version control, and build the application. And then we have the build step, which is each step in the build process. So what are the steps we are going to perform? As I had shown in the previous slide about the various steps in the CI/CD pipeline, each each one is called a step. So let's go back and look at the screen. So we have the version control, code check into the version control, and version control actually notifies the TeamCity, and then TeamCity will fetch the code through VCS route. That is first step. Once TeamCity fetches the code, it builds the application using one of the build agents, and it uses the build tools. Internally it can use Maven, it can use Gradle. That is internal configuration, again part of the build configuration. And once build happen, TeamCity will run the unit test cases by using another step, and once unit test cases are executed, it will generate the artifact, and that artifact will be stored in Artifactory. Let's say you already have a quality gate in place. In such case, TeamCity actually runs the quality gate to ensure there are no code violations, there are no coverage violations. If there are violations, it will send a fail notification. If there are no violations, it will go further. So that is another step. And once artifact is generated, we can have one more step which actually takes care of deploying the generated artifact in the server. And then we have a build trigger. So as I mentioned, like if there are code changes done by the developers, TeamCity should be notified, should know what about this event. So that is called build trigger. So version control tells the TeamCity, okay, these are the changes done by the developer and I have the latest code available with me. Then TeamCity will fetch the code changes and make the build. So that is the triggering point. So this is more like a VCS trigger, and this VCS trigger will automatically idea notifies the TeamCity so that TeamCity can start the process. Then we have change, which is more like any code changes done in the version control, and when they are checked into the version control, those changes will be notified to the TeamCity. So build, this is actually the process which is part of generating the artifacts, running the unit test cases, and deploying the application. Build queue, we already talked about this. So if there are multiple code check-ins happen, and if there are multiple versions available in version control, when we want to have the build for all the versions, if a version 1 is in build process, version 2 will be kept on queue, and once version 1 completes, version 2 will will be will be part of the build process for build and test and deployment. And last one is the build artifact. So build artifact, actually the generated output file, or in case of Java we can say it's a WAR file or EAR file, web archive file or enterprise archive file, and that archive file will be generated and will be kept in one of the repository. In our case we can say JFrog Artifactory. So that will be available in the JFrog Artifactory, and the same artifact will be used or will be deployed on different containers. So this is about the concepts of TeamCity.